Hi guys, and welcome to the Magic Show. In this magic trick I am going to teach you cryptography, RSA cryptography, and I am going to teach it to you in 5 seconds. Assuming you have Magic locally installed, you can click the evaluator and then type RSA and click Control space if you're on Windows, or function control and space if you're on a Mac. Then you can choose crypto.rsa.create to evaluate, and boom, you have an RSA key pair. Now by default, this key pair only has a strength of 1024 bits, but you can also override its key strength. There is a link in the description of this YouTube video to this web page where you can read the entirety of the documentation, and you can also see, if you go down to cryptography here, you can see how to override the bit strength of your key pair. And you can also provide a manual seed in case you don't happen to trust bouncy castles random number generator. Anyways, we now have a key. So I'm going to keep this key around. The way I'm going to do it is to simply open another browser window with the same URL. Then I'm going to type RSA dot function control space, and then I'm going to encrypt. Now I'm going to need some data to encrypt. I can provide it either as an expression or directly in here, like this. However, some was here, and this is a super secret thing. Alright, so this is the stuff I'm going to encrypt. Right, now yet again, here is the documentation for how to use. This is sign and verify though, but encryption. Okay, it takes a public key. Okay. Key, colon, then we can go back and we can copy our public key here. And then I can click evaluate. And I now have the above text encrypted. Okay, let me copy this thing, and then let me open up another one. Then I can do RSA dot decrypt. Now what I want to decrypt is on my clipboard. It's the result of the encrypt operation. Now I want to provide my private key. Here is my private key. And when I click evaluate now, I have decrypted the encrypted cipher text. Right, so I started out by creating a key pair. Then I encrypted this text. Then I copied the result of this encryption invocation here into my decrypt invocation here. Then I passed in the private key resulting from the create key invocation, and my hyperlambda slots was able to perfectly decrypt the message. Now, public key cryptography, which RSA is a so-called asymmetric cryptography algorithm. This implies that you do have a public key and you have a private key. The public key is supposed to be publicly shared with anyone wanting to send you secret messages. The private key is supposed to be kept privately only by you, which results in that data or messages encrypted using your public key can only be decrypted using your private key. So if you manage to keep your private key a secret, then anybody can send you an encrypted message, and you are the only one that can actually decrypt this encrypted message. So let's use RSA for something different. let's cryptographically sign some piece of data. RSA dot shift control space, and then let's do sign. We're still using the same keeper, except now I'm going to be using my private key to sign a piece of data. Colon, Thomas Hansen was here, and this is to be cryptographically signed. Okay, key, colon, paste, invoke, evaluate, and ta-da, here is a signature in DER encoded format. Sorry, not DER encoded, base64 format. It's basically just a bunch of bytes that's been base64 encoded. Now, if I copy this piece, or let me open another browser window first, and then I go back here and I copy this signature, then I can do RSA dot verify signature, colon, paste in the signature. Now I want to verify that this particular text was encrypted using this particular key. Now I use the public key to verify the signature. So let's check it out, and it didn't throw an exception. If it had thrown an exception, then the signature would have been tampered with, or the original message would have been tampered with. If I, for instance, remove one of the exclamation marks here, and I evaluate, then boom, signature mismatching crypto.rsi.verify, which means that somebody tampered with the message, which means that the RSA algorithm can no longer guarantee that this message was created and sent by the guy whom owned the private key. Right? So this allows me to transmit a message and cryptographically sign that message, such that anyone having my particular public key can then actually verify that this exact message originated from me and was never tampered with. Pretty cool. There's a link in the description of this YouTube video to this page where you can read the entirety of the documentation. In addition to that, there is a link in the description of this YouTube video from where you can download the latest version of Magic. And yes, you will need version 8.4.4 of Magic to make this work, which was just now recently released. Thank you for watching. Have a nice day.